right, guys, good morning. So we are going to spend the next probably 2 weeks kind of getting us ready for geometry. Just the basics, though, right? I mean, if we have some time, maybe we'll get into some of the angle ratios and stuff like ratios, right triangle ratios. But we're going to focus on basically what we kind of missed by skipping 8th grade and doing 9th grade, right? So some of you guys might have seen this last year. I'm hoping that actually all of us saw at least some of this last year, so hopefully this should be a review. But, you know, if you saw it last year, it was probably in May and June, so it may not be so fresh. But we're just going to review angle relationships. Because when you get to geometry, that's going to be one of the prerequisites that they're going to expect that you covered already in 8th grade. And since we all are doing 9th grade math and we skipped 8th grade, you know, it's something we just want to make sure that is fresh in our mind. So we don't have to talk about this for now. And again, if I was doing this in class, I would say name as many types of angles as you can. And of course, we talk about right angles and straight angles and acute and obtuse. Maybe a reflex angle, right? So someone always says, so this is our vocabulary, right? So you should be getting this in your notes. And of course, you know that, you know, we've got our kind of L shape here is our right angle, right? And we know that the reason that this is a right angle is because if we had 4 of them all together, right, we would make a full circle, and we know a full circle is 360 degrees. So if we quarter a circle and then kind of split it up, we get 4 right angles. And we also could do that with a straight angle. So if this is a right angle, then putting 2 of those together, as we see here, should give me a straight angle because it could be split into 2 90-degree angles. And again, take the other 2 90-degree angles and we have our 360, we've got our full circle. And someone says, well, how would we classify an angle, right? Because it's not listed here, that's more than 180 and less than 360. So what would that look like? Well, that would look like this, right? So in other words, right, I would say, well, the green angle right here, let's say, is 40 degrees. I'd say, well, what's the other part of this, right? That's what's called a reflex angle. So that would be, 360 minus 40 or 320 degrees. And we see that if we look at what we call a concave polygon, right? So this is a quadrilateral. So if we were to look at the 4 angles, we've got one little one here, one little one here, one little one here, and we've got this one kind of big one over here, and altogether those angles add up to 360. But I'm kind of going off on a little tangent here. But it's just, I try to address the things that people would say in class, right? A lot of you guys ask really good questions in class, and I want to try to cover as much as we can, you know. And if we do have questions when we're doing the lessons, of course, we're going to ask them. But I'm trying to cover that, as much of that as we can during the lessons. All right, so the 2 vocabulary words that we want to take from this are complementary, right, which means a sum of 90, and supplementary, which means we've got a sum of 180. So if you take a right angle and you split it up, right, those 2 angles, this angle here and this angle here, would be what we call complementary. They add up to 90. And if we take a straight angle, as we see here, and we split it up, this angle and this angle together would have to be equal to 180. We call them supplementary angles. So we can do this from pictures, right, visuals, as we'll do in a few minutes, or we can do it from text, right? Find the complement of a 10-degree angle. So complement means we want a sum of 90 degrees. So 2 angles are complements if they add to 90, right? So 30-degree angle and a 60-degree angle we would call complements or complementary because they add up to 90. So how would we find the complement of a 90-degree angle? We would do 90 minus 10, and we would say the complement of a 90-degree angle is 80 degrees. How would we find the complement of a 20-degree angle? We would do pretty much the same thing, right? 90 minus 20 is going to be 70. How would we find the complement of an x-degree angle? Well, this is where it gets weird, right? And when I do this in class, everyone says y. And at first I was confused, and then I realized that they were just looking at their notes. And if you see x plus y equals 90, it's maybe logical to think that that would make sense. But let's think about what we did for the first 2. To find the complement of a 10-degree angle, I did 90 minus 10. To find the complement of a 20-degree angle, I did 90 minus 20. To find the complement of an x-degree angle, I'm simply going to do 90 minus x. And I'm going to put 90 minus x degrees. And let's think about why this works. Well, if x was 10, 90 minus 10 would give 80. If x was 5, 90 minus 5 would give 85. It's always going to give us the correct complement because we know in order to find the complement, you would subtract the angle you have from 90. Now we need to use a little very basic algebra. We have 2 complementary angles that are 3x and 6x. So we'd say, well, the angle that's 3x plus the angle that's 6x has to be equal to 90. which gives 9x equals 90, which gives x is 10. And if x is 10, we say 3x is 30, and 6x is 60. So now we can answer the questions. Find the measures of the angles. The angles are 30 degrees and 60 degrees. So that would be our answer. All right, so for something like this, we realize that this is a right angle, right? And we don't assume, you know, if somebody gave you a picture like that and said x and 42, we actually couldn't solve it, right? Because just because it looks like a right angle doesn't make it a right angle until we see the box. That's our symbol, which we do see here. So if I was doing this in class, I'd say somebody give me an equation. And somebody say, well, why don't we just do this? And I'd say, well, you can. That's perfectly fine. But if that was, instead of 62, 3x minus 5, you're not going to be able to do that anymore, right? You're going to have to say that the sum of these two angles is 90 degrees. Therefore, x plus 62 equals 90. And therefore, when I solve it for x, I get x is equal to 28, which is the same thing we got up here, of course. But again, if both of them are variable expressions, the subtraction method's not going to work. And let's do the same thing, right? We know that this is a straight angle, which is 180 degrees. So one thing I could do is simply subtract, which gives me 145, but we want to make sure that we can do this using an actual equation also, right? Which is also, again, going to give us 145 degrees. And here we have an example where I can't do that. First things first, right? So I deliberately extend the ray on the bottom, right? So we don't need this. Because whenever I do this, someone will say 3x plus 1 plus 2x plus 9 equals 180. And I'll say, well, why 180? And they'll say, well, because there's a straight angle there. And then someone else will say, yeah, but the 90 on this side is not included. So you can really just forget about this, right? We're just considering this right angle. So we know that the sum of these two angles has to be equal to 90, right? So 3x plus 1 plus 2x plus 9 equals 90. So 5x plus 10 equals 90. So 5x equals 80. Right, so x is 16. Now, we did not solve the problem yet, right? It says find the value of x and the missing angle. Should be angles. So what did we do? Yeah, we found the value of x. We couldn't solve the problem without finding the value of x, but we didn't find the missing angles. So I would say, what do we have to do next? And everyone would yell out, substitute in perfect unison, which is what we're going to do. So we substitute our 16 here. 48 plus 1, which is 49. And I've got 2 times 16 plus 9, which is 32 plus 9, which is 41. So we think our missing angles are 41 degrees and 49 degrees. And I would say, well, how would we check that? And someone would say, go back and substitute in your equation. And then some other intelligent youth would raise their hand and say, but we can't do that because we made the equation. We can never check an equation that we created. And then someone would say, well, why don't we add these two angles? And if those two angles add up to 90, then we did it correctly. And that's correct, right? If the value of x that we found when substituted into your expressions, right, these being the expressions, if that gives us two angles that are in fact complementary, that add up to 90, that's our check. So if you wanted to do a little check, which is not necessary for the homework, but just for peace of mind so we know we did it correct, you would add them up. And we'll do that again over here, right? Find the missing angles and the value of x. So we know that this is a straight angle, which means we've got a sum of 180 degrees. So 5x plus 13 plus 2x plus 13 equals 180. So that gives me 7x plus 26. So that's going to give me 7x equals 154, which gives me x is 22. And again, that's part of it, but we haven't found the angles yet. So what's 5x plus 13? Well, we're going to do 5 times 22 plus 13, which is 110 plus 13, which is 123 degrees. We're going to do the same with 2x plus 13, which is going to give us 44 plus 13, which is 57. So what are the missing angles? We think that this angle is 123 degrees, and we think that this one is 57 degrees. And you know, these figures are never drawn to scale, so it's not like we're going to bust out our protractor and start measuring these things. These are not drawn to scale for a reason, so that we have to use algebra. And again, yeah, that maybe that looks like it's right, I don't know, but we want to check it. So we want to make sure that these angles, when added, do in fact add up to 180, right? If we had done this incorrectly, let's say we got x is equal to 10. If I sub in 10, I'm going to get 63 and 33. And when I add those, I am not going to get 180, which tells me that I made a mistake. So it is important, even though it's not required for the homework, that we at least understand what we can do to check. All right. So two angles are supplementary. So this is doing the exact same thing, except instead of using the visual, you need to use the vocabulary. So we can go back to where supplementary is in our notes. That says a sum of 180. So I know that 4x plus 5 plus x plus 15 has to be equal to 180. So 5x plus 20 is equal to 180. So x is 32, we think, right? So now let's see what else. Well, what's 4x plus 5? We've got 4 times 32 plus 5. 128 plus 5 is 133 degrees. And we've got x plus 15, which is 32 plus 15, which is 47 degrees, right? We think. So we think that the answer is the angles are 133 degrees and 47 degrees. But of course, we're going to double check just to make sure. And when we add these up, we do in fact get our desired sum of 180 degrees. All right, guys, so this is your now try. So this is where we would pause. And then we'd come back and I would solve it, right? So 3x plus 7x equals 180. So 10x equals 180. So x is equal to 18. Show the step, right? And if x is equal to 18, we're going to substitute. 3x would be 3 times 18, which is 54 degrees. And 7x would be 7 times 18, which is going to be 126 degrees. And of course, we're going to do our check, which proves that we in fact did this correct. And for the second one, we've got a right angle, so that's a sum of 90, or the two angles are complementary, so they sum to 90. That gives 9x plus 9 equals 90, which means that 9x is equal to 81, which means x is equal to 9. And we're going to go back and substitute. If x is 9, 4x is 4 times 9, so this is 36 degrees. 5x plus 9 is 5 times 9 is 45, plus 9 is 54 degrees. And 36 plus 54, to double check, does in fact give us 90. So we did it correct. All right, so what would normally be our classwork is, of course, going to be our homework, right? There's a topic that is not in our textbook, since our textbook is Algebra 1, which is 9th grade, and this is really an 8th grade, end of 7th grade into an 8th grade topic. And again, the reason we're reviewing it is you will be expected to know this when you start geometry, and even if you did it in 7th grade, I'm not sure how fresh this is going to be in everyone's mind. So as far as the questions that I want you to do, we are going to do the even numbers. We are going to 2, 4, 6, and 8. All right, so just be careful. For 8, the angles are 4x minus 3 and 5x minus 6. Okay, and they're supplementary, and the rest of them I think are pretty straightforward. So you're going to do this, in our notebooks or on loose leaf as we normally would. We'll upload the photo. Any questions or concerns, as always, shoot me a message.